This video, Cosine Application Part A, goes through the first half of solving an example cosine application problem. The second half of solving this problem is in the video called Cosine Application Part B on my YouTube channel. Here's the problem I will be solving. There's a water wheel that is 12 feet in diameter, and the bottom 2 feet of it are underwater. One revolution of this wheel takes 9 seconds. You notice that there is a leaf on the water wheel, and you time with your stopwatch that it takes 3 seconds for it to reach the top of the wheel. Write a cosine equation for this function, expressing the height of the leaf from the water in terms of time. So, this problem is asking us to create a cosine equation that models a specific situation. The first thing I would like to do is draw a picture of what is happening in this problem. The problem says that there is a water wheel that has a diameter of 12 feet. The problem also says that the bottom 2 feet are underwater. I'm going to draw some water here to remind us that these 2 feet are underwater. The problem then says that there is a leaf on the water wheel. So I'll just make a point for the leaf. And it takes 3 seconds to reach the top. This drawing can help us create a graph of what the specific cosine function will look like. Let's make that graph now. First, I am going to draw and label my axes. We know from the word problem that because it says to express the height of the leaf from the water in terms of time, time will be our x, and the height of the leaf from the water will be our y. So time goes on our x, and our y is the height of the leaf from the water. If I look back at the problem again, I see that time is in seconds and height is in feet, so I can add that as well. Now, I'm going to find some points to put on our graph. One point that would be very helpful in graphing our cosine function would be the maximum point. We can see from our drawing that the leaf reaches the maximum height from the water it can after 3 seconds. So right up here. So, our maximum point on our graph is 3 seconds, comma, the height of the leaf from the water, which we can see is 10 feet, because that is all that is above the water. So our maximum point on our graph is 3 seconds, comma 10 feet. Now we need to find another point to add to our graph. And first I will add this. So 3 seconds and 10 feet. So, as I was saying, now we need to find another point to add to our graph. We can use the point we just identified to help us out. If we look back at the problem, we see that it takes 9 seconds for the wheel to make one complete revolution. So, if we are at 3 seconds, 10 feet, and we make a revolution around the water wheel, we will have added 9 seconds to our total time, bringing us to 12 seconds. And since one revolution around the wheel is how far we went, we will be back at the same height of 10 feet. So, another point on our graph is 12 seconds, 10 feet. Now, let's find the minimum point on our graph. We know that the x value of this point will be directly in between the 2 points we have graphed that are at the maximum possible height for this problem. So, if we take the average of these two values, 3 plus 12 divided by 2, we get 7.5. So that would be our x value for the minimum. To find the y value of our minimum, we can refer to our drawing. We see that the lowest we can go is right here on our drawing. If we look at our label on our graph, we see that the y value is defined as the height from the water. Because our lowest height is 2 feet below the water, its height is -2 feet for our purposes. So, -2 is the y value of our minimum point. And we can add that point to our graph. Now, let's find 2 more points. Let's find a point between this point and this point, and a point between this point and this point. First, let's find a point between these 2 points. We can find the x value of this point by taking the average of the x values of these 2 values. So, if we add 3 and 7.5 and divide by 2, we get the average of 5.25. So, this will be the x value of our point. To find the y value of our point, we take the average of the y values of these 2 points. So, 10 plus -2 divided by 2 is 4. So that will be the y value of our point, and we can plot this point, which is at 5.25, 4. Now, let's find the point between these 2 points. We can find it in a similar way to how we found the previous point. To find the x value, we take the average of the x values of these 2 points. So, we add 7.5 plus 12 and divide by 2, and find our x value to be 9.75. Now, to find our y value, we take the average of the y values of these 2 points. So, we add 10 and 2 and divide by 2, and we get a y value of 4. So, we can plot the point 9.75, 4 on our graph. And now that we have found these defining points, we can connect them. And we see we have graphed a whole period of this specific cosine function. To see how the rest of this problem is solved, watch the video called Cosine Application Part B on my YouTube channel. If you found this video helpful, please go ahead and hit the like button. And also, please subscribe to my channel if you haven't already. And as always, thanks for watching.